and ready for a short, or not some short, for some application with point clouds, with TLS, with Cloud Compare. And I just want to remind you some thoughts, some theoretical stuff that I shared with you yesterday. So I present you some information about TLS, terrestrial laser scan. And if you were in my class, you saw that terrestrial laser scan, it's an application of electromagnetic radiation. Yes, we are using the laser part, a small part of electrical radiation to collect data from the field. So the data who's collected with laser, it has just information, spatial information, let's say like this. And what I mean with that, it's X, Y, Z. To have all this information colored, to have all the points colored, that is a process that the laser scanner equipments are assigned the color of the object to the point that has X, Y, Z. So today I will show you the data field collection. 1 second, share screen. This is the data field collection to the church that I share with you. You're gonna see that it's a wild environment and I hope you enjoy it. 1 second. It's just a small movie to see what we have to. Okay. And now I'm explaining to one of my students the process the process that we are that has to be taken with the terrestrial laser scan. As you probably see, I can see that it's a small delay. There are paper targets in surrounding areas. One is here, the other one is here. And these paper targets, as you probably remember, help us to do the co-registration or to bring all the scans, all the station scans in the same coordinate system. We place at least 7 to 10 targets in the area for each scan station. This is a laser scan, Zoroastrian and it's quite easy to deal with it. It was set up for a minimum points requirement. I mean, what I mean with that thing, there were 3 minutes for each scan plus another 3 minutes to do the panoramic pictures. The scanner is tilted. It has to be in horizontal position. Also, it has a compensator that bring it in the perfect location, let's say like that. And now what we have to do, just we have to wait that the scanner took all the datas. I think the images are, the movies are not going very smooth. You can see the rotated mirror. One sec, one sec. The rotating mirror, it's over here. And during the data collection, the scanners rotate horizontal with 360 degrees. And also this mirror is rotating vertical with 270 degrees because we have this area where the mirror cannot collect the data under the equipment. After we collect all the data, we are going to move the data from the scanner to the ZF laser control. As I told you yesterday, ZF laser control, it's a program specific to Zoller and Freulich equipment. In the left part, you can see all the scan station. If you already download what I sent to you, what is on the platform, you saw that you have this scan station in format A57. I opened the first scan station and the process is already done. I mean, we have already colored. It's not working very good. As you can see up, it's not responding. Okay. So all the scans are already colored. Yesterday, I told you that the first step is to color or to bring color to the point cloud. Here you can see a part, just a part of the point cloud, and you can see that the points are already colored. Also, in the surrounding area, there are a lot of points. These points, like B6, B5, BA1, B1, 23, and so on, these points are the targets. Look, this is CP1. CP1, in Romanian, it's control point from 3. This is CP1. You can see it here, yeah? Then we have CS1, CS1, and so on. So when we are choosing these control points, these targets, we can use, let me choose one that is stick. We can use the automated process but as you can see here, accuracy is not so good. If you are turning a little bit, we can see there are not so many points in our area. So we are not at least for this scan station, I didn't choose this paper target. Anyway, if you are forced or if you have to use it, I will use not automated, I will use it like manual. And I can try to find a point just in the middle. Okay, now it looks better. Yes, and we can see that somehow we find a point cloud in the middle of the target. Probably you ask why we have so less points on the object. Because we choose to have the precision of the 3D model very low. This is a didactic process or a didactic project. And because it's didactic, we didn't choose a very high quality because for high qualities, we need virtual machines to compute all the scans and to create the 3D model. We need like very strong computer, very strong stations. And for those reasons, I choose to have small or not so precise model to give the possibility of my students and to give the possibility of you to work and play with the 3D model. Here, I don't have the thermal camera, or I didn't use the thermal camera because we didn't need it. But if I wanted to use, I had to apply the thermal scans to the 3D model also. Another important process is to bring all the scanners in the same coordinate system. This is taking place with this button. And here you can see all the scan stations, and we choose one by one. Let's do the registration for these two. And we are trying to do the registration. In this window, you can see the quality. It's 90, 94, it's 85, the quality of the target. So 94, 95 is quite good. And then we can see the object. We will say, let's see a little bit the process. I think you're not seeing this. Why? Okay. So after we did the first iteration, we can see the report. And the report is telling us which are the problem, which are the best target to use, and so on. We have 4.5 millimeters, the average deviation of the target. So we have to, when we have this information, we have to take a look to the object, and the object, it's really damaged. I mean, you will see if you are doing the registration in Cloud Compare that this church has some serious cracks in the structure. So the 6 millimeters, the 5 millimeters, it's quite enough precision for these objects. We have to have in mind that the clouds will be will fill actually the same part of the church. So every part of the church is covered by three different scan stations, by three different clouds. So this deviation, this average deviation and maximal deviation, it's quite good for a kind a church like this or an objective like this. If well, if the our objective is a steel structure or concrete structure from built in nowadays, these deviations are quite big. But in our case, we can proceed. So after all this process, we have to combine scans. Combine scans, it doesn't mean that all the scans are creating a model. It means that all the scans or all the scan station actually are in the same coordinate system. So these programs, this kind of program, as I told you in the beginning, is specific to every brand, to every equipment. Leica has one, Trimble has one, Regal has one, but all these programs have the same principle, and the principle is coloring the point clouds. Yes. Let's try to find another one. You can see here, all the points are colored. This is just a part of it to work easily. Yeah, you can see it work easily, but all the points are colored, okay? And what is interesting to see is that we have 360, yes? I mean, we have all the environment 360 degrees. And also, what is important, we have our objective. So, what the programs are doing, they are doing this matching between point clouds and color. They are doing registration, and they are bringing the scans in the same coordinate system. Let's see if I have some questions. Okay, not yet. Good. Let's go in Cloud Compare now, because I hope you already installed the Cloud Compare. Someone installed the Cloud Compare, can you tell me? Yes, super. I just opening the Cloud Compare. I will share the screen with you. So this is the Cloud Compare software. If you made it, will be good because we can work together a little bit. So what we have to do, after we install the Cloud Compare, as I told you before, it's an open source solution. We just drag and drop the information. I will open my scan. And I will use 10 to 10, 10 by 10, because will be easy to work with. 10 by 10, it means the 10 point from the scan. The 5 by 5 is mean the fifth point from the scan. So it's not a full precision. Also, if you are working, if you want to work with full precision, but I don't know what computer are you use, you can have one-to-one. But let's try with 10 by 10 to see what happens. Okay, something happened in the left part. Yes, we already have a point cloud that is introduced in our software. Okay. To see it better, yes, you can use the scroll to zoom out and zoom in, and left and right button to work with our or with the point cloud. But as you can see, where we are just dragging and dropping the information here, the point cloud, it's not colored. You can see here a little part of the charge is the first part. But if you are choosing RGB, as you can see that the part is colored. What does mean 270 degrees that the scanner cannot see? Is this point, is this part that is placed under the scanner? You can see? But of course, it can be seen from a different scan station, so we don't have the problem. So as you can see, the points or the dots are quite rare. And this is because we have just the 10th point between this point and this point. 1 second, are another 9 points, yes? And if you are working with the one by one, it's even better. So we are not interested in all these data. We are interested just in this part, and we have to delete a lot of it's called noise. Yes, what is noise? It's all the things that we are not interested in. So if if you want to keep this stream, it's okay. But for my application or for this application, we didn't need all this information, and we will delete all this information, and we'll all this information, yes, we'll delete it, and we will keep just the structure, just the church itself. So to delete it, we have to make it active. So it has to be blue here, and we have to try to find the segmentation, the scissor. You can see here a scissor, okay? And if you are using this button, another buttons show up over here. To do the segmentation, we just have to choose a rectangle area and close it. And deleted. Yes, we keep what it is inside of our rectangle area, and then we are confirmed. If you are satisfied, we are confirmed the segmentation. Now we have 2 point clouds, one with everything, and the other one, what just with our segmentation. So because we don't want everything, just our segmentation, we are keeping that one, and A1 remaining, we will delete it. Okay, and now we have just the church itself. So we are continue for all the scans this process, and this it take a while, but we are at school. What we have to do? Again, we are activating the second point cloud. We are choosing RGB, and you can see that the church is looking better with every scan that we are. I try to go slow because there is a gap between what I see and what you are seeing. Okay, I forgot to tell you that we have different views, so we can use these buttons to have different views, and you can play with, and we'll proceed with the segmentation process. Of course, if you have 50 scan station, you will do for the 50 scan station the segmentation. You will delete the noise. But also, this process can be made after we will integrate all the scan station. But I will not recommend you to integrate all the point clouds, all the station, and then you make the segmentation. Why? Because the program, in a lot of cases, will crack. Even the program, even the computer. So even if it's time consuming, I hope that you will do your segmentation station by station or cloud by cloud. So it's activated. I will take a look at the chat after I finish this segmentation too. Yes, easily. I close with the right button as the segmented area. Then I keep just what I have inside, and I confirm segmentation. Okay. Then I will delete what I don't need. I mean, I delete remaining. And now, let's use this button. What do you want on? Ah, okay. We have just what we are interested. What it's important to know is that this scan, it's made outside, and also we have inside information. This is quite nice because in the end, you can you can do the section, you can reconstruct the walls, you can measure the thickness of the walls and all this structural information. Okay, let's see if we have some questions. Oh, okay, then I have a question. You made it? Someone made it? Is it someone made it? I mean, what I did, just to do the segmentation, to integrate the point clouds. This is the question. I mean, if you made it to introduce at least couple point clouds, to, if you did the segmentation, and it's a long process. This process can take about 1 hour, 1 hour and a half. Probably you will do it later. So the next one. I still have a long way because I still have from 3 to 23. I just did 2. Maybe I will not integrate all the scan station, but I will still integrate some of it. We will need data for, but I think the data is already in the system. I asked Professor Liang to upload the data. Do you have the data?
Yes.
Okay. Okay, perfect. You have downloaded the data and then try to upload in the process. Okay. So now I have A3, the point cloud number 3. What we have to do? First of all, to see what we have here. Someone already did that thing. Okay, super, fantastic. And how it looks yours? How it looks your church? Usam Ali Khan. How it looks, the church? After you did all the segmentation. Hope it look good. Okay. We'll start the segmentation. Okay, what's happened? Let's try to do another one. If you are choosing the wrong button, we already have 4 structures here, or 4 point clouds. Let's do the segmentation again, easily. Yes, and if you are choosing the wrong button, I didn't choose wrong button, it means that I choose the segmentation out and our information was deleted. It's not a problem. We just have to delete both of it We delete A4 remaining and A4 segmentation because we delete what we didn't want, and we'll integrate again A4. Okay, so if you are doing step by step or point cloud by point cloud, and you are doing the segmentation, you have more control about the process that are you doing. Okay, let's doing the other one, the fourth one. Someone tried also to do the segmentation with one by one with all the information, because this is just 1 by 10. Someone, let's see. Please let me know in the chat if you try 1 by 1, not 1 by 10. If someone. Definitely the process, it's a little bit longer, but the information will be much, much better. Okay. Delete. Good. Our objective, yes, it's coming and it's better with all, with every. Yes, you can play with it. Okay. After we will do all the segmentation for all the scan position, we have to merge. What it mean merge? We still have 20 here, 4 objects, not just an object. To be easier to process later, we have to do it all these point clouds to do just one point cloud. So to merge all these point clouds, we have to select all the point clouds or the point clouds that we want to merge with control and right button, left button. And it can be seen that all the points that all the point clouds that we have are selected here, right? And then we have to merge multiple clouds. Yes. And now we have just an object. You see, we can delete the other ones. Yes, delete. And as you can see, we have just one object. Of course, it looks better now. And we can work very easy with the object, yes? If you can see, it's working very easy. We have just one registered point cloud object. Good. Let me see the chat. I think that you have a tutorial in the platform where you can have, where you have all this information. Okay, we'll continue till the end. We have the fifth point cloud. We zoom in to see it better, and then again, the segmentation process. Segment in, confirm, and delete what we don't need, the noise. Okay. Drag and drop. Why we don't have the six? In the sixth station, I had an error on the field. So I deleted on the field, and the program of collecting data continue with 7. So it's not a mistake. I just delete erroneous point cloud data collection. Also, from ZF laser control, from the program that I show you before, we can delete also the information who's not accurate. Why is not accurate? Maybe the battery ran out, and this was the case because I didn't, usually the battery for this laser scan, it's staying for 5 hours easily, but it wasn't completely charged. So the battery ran out, and the scanner stopped suddenly. Also, I told you yesterday, if we have a vibration, again, the scanner will tell us that the vibration are too big, and if we want to continue or not. Even if the scanner have in it the compensator, some vibration are not proper with the process of collating data. Yeah. So that's why I don't have the 6 scan. And all this data or all this information, we can delete it on a field, or it can be deleted in the Zollern-Freulich laser control, in the program that is processing the first part of the scanning. So I will continue now with the 7. Yes, we start from here. The first our station was here, and then we came and I surround the church, and then you'll see I'm went inside, outside, and I stopped in this part. But we are just on the 7th one, so we are still have to do the segmentation. The process of segmentation depends on how big is the uh, point cloud, how dense is the point cloud, and also how good is the computer there that you work with. But time consuming is not necessarily this segmentation. This is a recurrent process, but time consuming uh, is the process where the points are colored. That process can take, in some cases, 24 hours or maybe more. So the coloring process, the coloring all the dots, it can take more than 24 hours. In this case, the process of coloring point clouds took me around 20 hours. And it's a process when we have to stay aware to see if it's working well, if we don't have the errors. So it's not running by itself. We still have to do some intermediate steps in the process of coloring the point cloud. Okay, continue. Deleting. Good. Next one. Okay. I have to zoom in a little bit to see it better. The 8. Where is the 8? We cannot see it. It's in this area, but it's still gray and black. The points are still gray and black. Why? I forgot to color. The points are already colored. It just shown RGB or not colored. Yeah. Okay. Segmentation process. And we will delete what we don't need, the noise. Okay, let's merge this one too. Control and left button to select the other one, control and left button, and we're selecting the 7. Control at left button, and we're selecting the 8. And merging. Merge multiple clouds. Yes. Okay. Deleting what we are not, we don't need anymore. Our objective is looking better and better with the next point cloud that we are integrated in the software. So for those of you who have access to Pi software, I will encourage to do this process also in the Pi software. F57, it's a very common extension for point clouds. And definitely, it has to be accepted also by the Pi software. So for the student from China who probably have the access, and probably you have also the access to the this software, please try to process this information also with the Pi with the Pi software. Okay, we are integrated the ninth one. Coloring. What it's interesting to see that we have points measured by scan station to a quite high distance. This, I think it's more than 200 meters, it's 300 meters. And of course, maybe in some cases we need these distances, but the precision for these points it's relatively very less. So that's why we call all this information noise, as I tell you before, okay? Thank you. Thank you, Professor Liang. So you have access to the Pi software. I wanted to work a little bit with the Pi software, but I didn't have enough time to get familiar with. So if you are familiar, if someone is familiar, and I know that you have forum here, we have chats. So if someone is familiar with the Pi software and with the point clouds, please share the information, because what we are doing at this summer school, we are just sharing the information. Me from Romania, my colleagues from China, from US, we are sharing information with you. And I hope this information that it's shared, it will be very useful for you in the future. Not just my information, I mean to all the information that it's shared. Okay. I'm satisfied with the segmentation. And then I delete what I don't need. We can see here a part that it seems that it's the inside, but it's not the inside. These are just the points from this part, who are measured from this part of the church, you see? You will see better when we have the inside information, it's quite different. So from now, we have just outside the information, not the inside. Okay, let's go further. 10th. Okay. And delete. Okay, we go to the 11th one. Make it available in RGB. I really hope that you are enjoying this process. Even if it's very repetitive. Why is encouraging for me when I'm doing this process is that even if it's repetitive, with every point cloud, my objective is looking better and better. So this is really encouraging for the point clouds, for the people who are doing 3D determinations. Let's merge, control, control, and left button, control F left button, and merge. As you can see, it's almost instant, the process, but you have to have in mind that it's just 1 point from 10. Yes, this is just for understanding the process, to have all the information. This is we are not, maybe some people are using, but we are not using information like this. I mean, we will take one-to-one. Okay. Maybe I have a little noise around me. This is the environment where I am today, but we'll continue. Any questions? Let's see if I have questions. I can see that Paul Zdrenga is here. Good morning, Paul. He's my PhD student. Paul, I would like to ask you to share the link in the chat with the software. Beatrice. Thank you very much, Beatrice. Thank you. My colleague. Another question? Super. Good. Going further. segmentation in, confirm, and deleting. Going further, we have 13. I'm going a little bit faster. Okay. 14. Drag and drop. Thank you, Professor Liang. You are doing a great job. I think you are tired, but you are doing a great job looking on the chat and give all the information to the students. Thank you. I really appreciate your hard work. One sec, I have to see it better. Yes, doing the segmentation. Okay. Again, I will merge what I did already. Merge. As you can see, the name changed. Why? Because I start to merge with the A14 point cloud. This is not a problem. I'll not delete this one. Good. Nice. Okay. We still have some, not so many, but we are doing all of them and then we're taking a break. Okay. Zoom in. Segmental. The structure looks a little bit different, as you can see. So why? Because this point cloud, it's already from the inside of the church. Yeah? We are not, we can see the walls. These are some windows. Yes, but you can see actually sometimes if we have just inside, we don't need the segmentation for this one because we have just some information that was captured. This station, I think just it was in this part, and we have just some information that was captured through the door. The door was open and we have some noise in this part, and we can leave it or we can delete it as you wish. I will leave it from now on. And we can delete it in the end anyway. So going further, 17, it's again from inside, as I remember. You can put 18 too. Okay, let's see what we have now. So we have 17, let's color 17 and 18. Okay. We are zooming in. And yes, it can be seen the inside of the church. You can, the cloud is not so dense because we are working with 1 by 10, but we can, let's put it upside down. Let's rotate the church upside down. Let's see from the bottom. Yes, because it's 1 from 10, we can see through the clouds, through to the point clouds. But anyway, we still understand at least structural some information from civil engineering part of view. I mean, we can do it sections now. We can, okay. Okay. Let's merge this one too. Okay. We still have 4 or 5 point clouds to introduce. Let's see the 19. Let's delete what I don't need. Okay. Also, it's from inside. It's perfect. So we don't need a segmentation. 20. This information is took it by the windows. We have in this part some windows, and we have some noise here because I think it's part of the tree. Yes, but we don't need it. We will cut it later. Don't worry. So we still have 21, 22, and 23. Well, okay. So 21, it's outside. So we need to do a segmentation because no. From inside, we can proceed. 21, 22. Let's say, where is 22? Okay. We come outside with the data collection, and you can see that we have a lot of noise here that it has to be deleted. Okay, let's delete this one too. First of all, I will place the up view, the top view. Okay. And the last one, okay. Okay. Let's delete the noise. Confirm. Delete. Okay. Let's merge. And we practically, in this point, finishing all the process of bringing point clouds in the same is still in the same coordinate system and also in the same file. I will delete what I don't need. And I will do another segmentation in the end, because as you can see, I still have some information that I don't need. Okay. Good. Okay, let's take a break. And hope I still have enough battery of this laptop. I will see you in 10 minutes from now. Okay? Let's have a small break and I will see you in 10 minutes from now. Hope you have enough time to drink a cup of tea or a cup of coffee. Okay. So from this point, you do what you want to do with your 3D model. And what I suggest you, because the other laptop runs without battery, I start to open my presentation from here and to give you some clues about what you can do. Actually, in the end, I will talk with Professor Liang, but probably the most interesting thing for you and for the Simon will be to share with me a small video, if you can insert a video in the platform with your objective. But after the point cloud segmentation, your church is looking like this. On this computer, I don't have the cloud compare, so I'm using the presentation. So what we can do, from civil engineering point of view, what it is important is to have cross-section or section. So in the tools menu, you have segmentation and you have cross-section here. So I encourage you to use this command to do the cross-section and also to extract this cross-section and maybe to integrate it in a CAD program if you have. It's very easily, yes, you can do the cross-section with the buttons. If you activate what you have in mind, sorry, if it's all the time, you have to be sure that the point cloud is activated. It's blue. If it's not blue, it's not show you this cube. Yes, if it show you this cube, it means that point cloud is activated. Without activation, you cannot do any process on the point cloud, on the 3D model. So I would like to have from you some of cross section, like vertical, transversal, horizontal cross section, just to do some cross section and extract the element that are defined or that you can see in these cross sections. Yeah, you can see here inside it's more dense. Of course, it's more dense because the distances from the scanner to the objective, to the walls are closer. And here you can see the outside walls. Okay. This is a transversal cross section. We can measure coordinates also, X, Y, Z. We can measure distances here. We can create 3D objects by vectorization process. As when we are choosing not the right one, and when we are choosing the right edge, you can see here is choose the right edge. And also, what I want from you is to do a small video. This video can take a while, between 5 and 10 minutes, maybe more, depending how many scenes, how many points do you want to take. But you have in this presentation all the steps that you have to do in order to create a video. And I will show you the video that we created. One sec. Oh, it's not working. Oh, no. I will put the video also in the platform because I'm not sure why it's not working here, but I will put a video in the platform. I will send it to Professor Liang. So it seems that you have some stuff to do, and I wanted to use this period of time that we still have around 1 and a half to work to your point clouds. So if there are some questions, I'm here and I'm available 5 or 10 minutes more. If there are not questions, I will let you work by yourself with the point clouds that you already have in the platform. So if there are some questions. Anyway, I will really want to thank you for attending this class. I will really want to thank you for your attending this platform, this summer class. And I hope that we can see in the future online or physically. You have all the information in the Moodle platform. And I will also tonight or tomorrow, because I'm traveling today, I will put the video to see, and I will give you the assignment tomorrow morning, Romanian time. So thank you, and hope you will use the software that are creating 3D models, because this is the future. Actually, uh, in the near future, will be not easy for us to make distinction probably between virtual reality and physical reality. But what I'm sure that we need specialists that are capable to work with 3D models, to create 3D models, and extract valuable information from it. So it was my pleasure for me to work with you and with Professor Liang and the other colleagues. And in the end, um, I would like to ask you politely to open your camera to make a print screen from the end and just say hello. If someone is here, okay, super, super. If there's someone awake in this room, I'm very happy to see your faces, smiley faces. They're so nice to see faces, not just some dark dots with some names. Okay, super. Thank you very much. Thank you, thank you. Bye-bye, and have a good class in the next days. Bye-bye to everyone. Professor Liang, if you want to say something.
Bye bye, teacher. Thank you so much.
Yes.